You just launch your first API, you send the link to a couple of friends, and then the whole thing goes down. Not because of a bug, not because your server was weak, but because multiple people refreshed at the same time. If you ever wondered why API have limits or why your app starts throwing error when traffic spikes, this video is going to change how you build things forever. Let me tell you about a real scenario. A small fintech startup built a payment status API. It was clean, it worked perfectly in testing. Users could hit an endpoint and boom, instant response. The first few days, customers were happy, the team was happy. Then a client integrated their app. And here's where it gets interesting. That client's app had a bug, a small innocent bug. Instead of checking payment status once, when a user opened the page, it checked it every 200 milliseconds. So a single user opening the app, that's 5 requests per second from one person. Now imagine 200 users open the app at the same time. Yeah, that's 1,000 requests per second. Just from one integration, the server had no idea what hit it. Now, here's what nobody thinks about when they build their first API. They think about the happy path. They think about their own tests. In a perfect world, user click button, server processes request, send response, done. But production is chaos with a smile. The team had decent infrastructure, they had a load balancer, they had database connection pooling, they thought they were prepared. And for normal traffic, they were. Everything was measured, everything was optimized. But there's one thing they didn't account for. They had no protection against their users breaking them by accident. No cap on how many times a single IP could call them. No limit on requests per second. So here's what actually happened when the traffic spiked. The server started slowing down. Response times went from 80 milliseconds to 400 milliseconds and then to 4 seconds. Then requests started timing out. And here's the twist that gets everyone. When requests time out, what do users do? They retry. So now you have a server that's already drowning and the people drowning it are sending more water. The database connection pool maxed out. New connections got refused. The app server started throwing errors. In about couple of minutes, their entire payment API was offline. Not because of an attack, not because of a deployment, because of a single misconfigured client. This exact scenario is why rate limiting exists. In technical terms, rate limiting is a policy that controls how many requests a client can make to your server in a given time window. For example, each IP address can make a maximum of 100 requests per minute. If you hit that limit, you get a too many request response. That's it. That's the core idea. But how you implement, here's where most engineers mess up. They think rate limiting is about stopping hackers. And yes, it handles that, but that's not the primary reason you implemented it. The real reason is fairness and stability. Imagine you have a public API with 10,000 users. If one user makes 50k requests in a minute, they are eating resources that every other user should be sharing. That's not malicious. That's just a bug. But without rate limiting, their bug becomes your problem and your other user's problem. There's another thing people miss. Rate limiting should be layered. First, at the edge, your CDN or reverse proxy like Nginx or Cloudflare handles the obvious stuff, stops brute force before it even hits your app. Then, at the API gateway, this is where you apply per user, per plan, or per endpoint limits. And then, if you're serious, at the application level too, because your gateway won't always know the cost of each operation. A request that triggers a heavy database query is not the same as a request that returns cached data. If you are running multiple servers, which ideally you should be, you can't store the counter in memory because server A and server B don't talk to each other. You need a shared store, and Redis is the go-to here. Fast, atomic operations, built-in TTL. When to use rate limiting? On every public-facing API, no exceptions. If someone else can call your endpoint, rate limited. It should be default, not an afterthought. You should not use rate limit internally. For example, internal service to service calls. If your ops service is calling your user service and you rate limit, that too aggressively, you will start getting 4 to 9 inside your own infrastructure. That's embarrassing, and it's happened to bigger companies than you think. Also, this is very critical. Always return a useful 4 to 9 response. Include a retry after header. Tell the client, hey, wait 30 seconds and try again. A rate limited client that gets no guidance, they just retry instantly. So, back to that your first API. The good news, they came back online in about 20 minutes. They implemented a basic rate limiter using Nginx, 100 requests per IP per minute, deployed it, traffic normalized. But here's the thing that stuck with their lead engineer. He explained me, we never thought we needed to protect our API from our own users. We thought we only needed to protect it from the internet. Turns out the internet is your users. That's the real lesson here. Rate limiting isn't a security feature. It's not even really a performance feature. It's a trust feature. If you like the video, hit the like button and subscribe to the channel.